Unit 3 Transformations, Lesson 3-2, continuing on with translation. Lesson 3-2 Translations Objectives. Number 1, translate a figure and write a rule for a translation and use vectors and vector notation to perform translations on geometric shapes. Translation is a transformation to vertically or horizontally slide a figure. Look at there. All right. Symbolic form. It takes any point xy to the point x plus h and y plus k. H represents the horizontal shift because it's being added to x, which is the horizontal variable. There we go in the diagram. And k represents the vertical shift. Rigid motion. Just a reminder, when a transformation preserves the shape and size of a figure, it's rigid motion. All corresponding angles and sides of the image and pre-image are congruent. Rigid transformations. Let's see. Reflections we did in 3.1. Today is translations, and then lesson 3.3 is rotations. They are all rigid motion. Coordinate notation. Example A. We have two figures. One is the pre-image, one is the image, and we have to figure out the rule which describes this translation. So let's see what happens from D to D prime. We're going to the right 7, so that changes the x value by adding 7, and we're going up 4. So the rule is it takes any point xy to the point x plus 7 and y plus 4. Let's do it again. We have two figures. One's the pre-image, one's the image. Let's see. There's a whole lot of stuff that if we go from the pre-image to the image, things are going to be on top of each other. So let's use the P's. So we are actually going left with the X. So that's a -4. We're going 4 units to the left, and we're going 2 units up. So that's positive. So our rule, it takes any value x, y to the point x plus -4 and y plus. Translation, example 1, rectangle QRST with vertices Q, -6, -1, R is at -3, 1, S is at 1, -5, and T is at the point -2, -7. Here's our rule. We're going to take every point x, y, and it's going to go to the point x plus 5, y plus 7. So we're going to the right 5 and up 7. Point Q is at -6, -1. We're plotting our original shape, the pre-image. R is at -3, 1. S is at 1, -5. And point T is at -2, -7. There's our rectangle. We are going right 5 up 7. We can add 5 and add 7. Add 5 to the x, add 7 to the y. I have that work off to the right. Or you can use arrows like I did. Q prime is at -1, 6. Add 5 to the x, add 7 to the y. R prime's at 2, 8. Add 5 to the x, add 7 to the y. S prime is at the point 6, 2. Add 5 to the x and 7 to the y. T prime is at the point 3, 0. Triangle. This is example 2. Triangle SDE has vertices C at the point 2, -1. D is at the point 7, -4. And E is at the point 4, -6. Here's our rule. We are taking every point X, Y, and we are translating it so that we go to x minus 3 and y plus 8. So we're going left 3 and up 8. Original point. 2, -1 is where C is. D is at 7, -4, and E is at 4, -6. There's our pre-image triangle. Now we can calculate by subtracting 3 from the x and adding 8 to the y. C prime is at -1, 7. Or we could go left 3 and up 8 and get to C prime at -1, 7. As subtract 3 from the x, add 8 to the y. D prime's at 4, 4. Subtract 3 from the x, add 8 to the y, and E prime is at 1, 2. And there's our image, C prime, D prime, E prime. Translation practice 1. We have a square, W, X, Y, Z. Vertices for W is at 1, 7, X is at 6, 5, Y is at the point 4, 0, and Z is at the point -1, 2. Here's our rule. Every point X, Y goes to the point X minus 7 and Y minus 6. So we are going left 7 and down 6. Original points. The pre-image. W is at the point 1, 7, X is at the point 6, 5, Y is at the point 4, 0, Z is at the point -1, 2. It is a square. All sides should be congruent and all angles should be right angles. Let's do our calculations. Or we could go left 7 and down 6. So subtract 7 from the x, subtract 6 from the y. We're at -6, -1, left 7, down 6. There we go, W prime. Subtract 7 from the x, subtract 6 from the y. We're at -1, -1. Subtract 7 from the x, subtract 6 from the y. Y prime is at -3, -6. Subtract 7 from the x, subtract 6 from the y, and Z prime is at the point -8, -4. There is our image, and they should be congruent squares. Practice 2. Let's see. Triangle STU has vertices. S is at -4, 2. T is at the point 5, -1. U is at the point -2, -2. Here's our rule. Takes every point x, y, and goes to the point x minus 1. So we're going left 1. Y minus 5, going down 5. Original point, -4, 2 is S. 5, -1 is T, and U is at -2, -2. There is our triangle. Looks pretty obtuse and scaling to me. Let's see, we can subtract 1 from every x and subtract 5 from every y. S prime's at -5, -3, or we could go left 1 and down 5 and get the point that way. Subtract 1 from the x, subtract 5 from the y. We're at the point 4, -6. S prime, by the way, was at -5, -3. U prime. Do the same thing. Subtract 1 from the x, subtract 5 from the y. We're at -3, -7, and there is our image. Vectors. A quantity with both direction and magnitude, which is size. A vector is represented in the coordinate plane by an arrow drawn from an initial point, P, to a terminal point, Q. So one is shown over there in the diagram to the left. The vector is denoted as, there's our notation for vector PQ. It's like a ray symbol, but it only has the top part of the arrow. That's what makes it different than a ray, because this does have an ending point, a stopping point, the terminal point. It does not keep going like a ray does. The component form of a vector is written as vector PQ equals, and then we have these brackets. There's not less than and greater than signs, okay? It's just pointy brackets is all you do, and that's A and B. A is the horizontal component. And B is the vertical component. There's our horizontal component on that one. We're going right 4. Vertical component is up 7. So we can write that as vector 4, 7. Not parentheses, is not a point. That is how you write a vector. 4 to the right and up 7 is what that shows. Name each vector, then write the vector in component form. Number 5, that is vector WV, like West Virginia. Let's see. Initial points W, terminal points V, so that's where it ends. The arrow shows us which direction we're going in. Component form, we're going right 9, up 3, so that is written this way. Right 9, up 3. Number 6 is vector BA. Initial points B, terminal points A, because that's where the arrow's pointing to. So it has to be BA. And we are going left 5, up 1. So that is our component form. Number 7. Initial point is S, terminal point is R. So that is vector SR. And component form, let's see, we're going left 2 and down 11. So that's how we would write it in component form. Number 8, this is vector BC. Initial points B, terminal point C. Arrow tells us which direction we're going in. And we are going right 2 and down 2. And that is a component form of the vector. Number 9, let's see, initial point's M, terminal point is N, so we have vector MN. We are not going left or right, but we are going up 6, so no change in the X, up 6, so positive 6. Number 10, initial point H, terminal point G, so vector HG. Let's see, we are going left 11, but no change in the Y. So that's the component form of that vector. Translations with vectors. Example 1, we're going to graph and label each figure and its image under the translation along the given vector. Identify the coordinates of the image. So I have a table there for us. We have triangle STU. The vertices, S is at negative 3, 7. T is at negative 2, 1. And point U is at negative 5, 2. So there is our pre-image, triangle SUT or STU. Doesn't matter. Our vector is negative 1, negative 5, which means we are going left 1 and down 5. In Delta Math, we would have problems like this, where you are doing a translation using a vector, and you're going to have to make the vector at the origin. So there's the vector. We would be going left 1, down 5, and then you would place that at each of the pre-image vertices, and it will automatically make the new shape, the image, for us. So let's do some calculations. Because we're not in Delta Math right now, negative 3 minus 1 and 7 minus 5. There's that vector, and it takes us to negative 4, 2. We subtract 1 and subtract 5 from the original coordinates. Negative 2 minus 1, 1 minus 5. We can put that vector in, and we're at the point negative 3, negative 4. Do our calculation. Negative 5 minus 1, 2 minus 5. We end up at negative 6, negative 3, and we can use our vector to get that. And there is our image. Triangle S prime, T prime, U prime. Translations with vectors, example 2. Graph and label each figure and its image under the translation along the given vector. Identify the coordinates of the image. Triangle EFG has vertices E at negative 7, F at negative 2, negative 3, and G at negative 1, negative 6. There's our original triangle. That would be our pre-image. We're using the vector 8, 3 right there, which means we're going right 8 up 3. In Delta Math, you would be making that vector and then placing it on each of the vertices, E, F, and G, and it would automatically translate it for you. How cool is that? So let's see, let's do our calculations. Add 8 to each x, add 3 to each y. E prime is at 1, negative 4. Add 8 to each x, add 3 to each y. There's our vector. That's at the point 6, 0. Add 8 to each x, add 3 to each y. And there's our point G prime is at 7, negative 3. And there is the image after that translation using component form 8, 3. Describing translations using vectors. So we need coordinate notation and component form as a vector. So we need to figure out where our initial points are and where the terminal points are. So looks like if we're just doing W to W, just to get, I don't want everything that's all up on top of each other. Okay, so from W to W prime, we're going left 4, and then we're going down 3. So component form takes every point xy to the point x minus 4, y minus 3 as a vector in component form. That's using the vector notation and negative 4, negative 3. Next one, look for your initial point and your terminal point. We are going right 1 and down 7. So coordinate notation takes every point xy to the point x plus 1, y minus 7. And there it is as a vector. We're going up 1 and left 7. Fill in the blanks. A blank slides a figure from one location to another. Of course, that's translation. Congruent figures have equal corresponding sides and angles. What is the image point of the 0.94? So that's our pre-image after a translation, 5 units left and 1 unit up. So we need to subtract 5 from the x and 1 being added to the y, and that's going to take us to the 0.45. That would be the image. Same kind of question for the next one. We want the image point of the original point, pre-image, negative 5, 3. Translation is 3 units left and 1 down. So subtract 3 from the x, subtract 1 from the y, and that's at negative 8, 2. There's a couple different translation problems in Delta Math, and one of them is where you are just plotting all the points. So we have an original triangle there. The points, the coordinates are not labeled. That is fine. You can just count from each of the vertices and go left 6, down 3. So there is that top left 1, left 6, down 3, left 6, down 3, left 6, down 3, and there is the new triangle. Here's another one where we're going to translate it using a vector. So translate the figure 5 units right, 1 unit down. And notice the yellow dot in the middle. That's where we're going to make our vector. So draw a vector from the origin, that yellow dot, 5 units right, 1 unit down. There we go. And we're going to place that at each vertex by grabbing that tail. And when you do it to each vertex, once you hit the very last one, it's automatically going to translate it for you. And so the pre-image was the red and the image is the blue. A couple more Delta Math problems. Let vector v have an initial point of 6, 2, terminal point of 1, negative 3. Determine the components. Well, we have to see what happened to go from 6 to 1 for the x's and to go from 2 to -3 for the y's. Give us the terminal point and the initial point. We can subtract terminal minus initial. So 1 minus 6 is -5. -3 minus 2 is -5. So we're going left 5 and we're going down 5. Let's do the same thing with the next one. We're going to take our x and subtract terminal minus initial. 1 minus 5 is -4. And -8 minus -3 is -5. Delta math example, identifying translations, guided. Determine which translation would map figure Q to figure R. So we're going from the blue to the green. So make sure you are using that to fill in the blanks below. You're going to determine left or right, up and down, and by how many. So pick a point that you are going to be counting from. So I used that point right there, and I went left 5 and up 8 to get to its corresponding point. So I would select left 5 and then select up 8. And that's how you would fill in that problem. 8, the image of the point -9, -3 under a translation is -12, -8. Find the coordinates of the image of the point -4, 6. So we have to figure out what the vector is and then do the same thing with the new point. So we are going from -9, -3 to the point -12, -8. So there's our initial and our terminal. Terminal minus initial is going to give us our vector. So -12 minus -9 is -3. And -8 minus -3 is -5. So there's our vector. We need to use that with the point -4, 6 to get where it ends up, where the image point is going to be. So subtract 3 from our x and subtract 5 from our y, and we're at -7, 1. Same thing on this one. Terminal minus initial. We're going from point 2, 1 to point -3, -2. Initial, terminal. So for the x's, -3 minus 2 is -5. For the y's, -2 minus 1 is -3. There's our vector. So we're going left 5, down 3, and we have to do that with the point -2, -9. So -2 minus 5, -9 minus 3. We're at -7, -12.